In this video, we're going to be talking about the inclusion-exclusion principle of probability. And that principle states that for two events, E and F, the probability of either one or both, right? So remember this union is like or in the English language. So E or F, potentially both. The probability of that happening is the same as the probability of E individually together with the probability of F individually, but then you have to subtract off where they overlap. And we're going to talk about that in just a second. And this in purple is the same formula where I've just added and subtracted a couple of terms, right? So like I added the probability of their intersection to both sides and then subtracted the probability of their union from both sides. So really this principle, what I've written in green here is the main way we usually write it, but this is the exact same thing written in purple. So let's talk about why this is true. Okay, so the probability of E union F, so that in this Venn diagram represents literally everything, right? So all of this that's inside both of these two circles, that's what we want, okay? So let's see why it's this equation. So first it's the probability of E, right? So you take everything in E and see how likely it is to have happen. Let me just get a different color here. And then you take F and everything in F, you add that in, right? But now look, where they overlap, we've double counted, right? We counted in red and we counted in blue, which is why you're supposed to subtract off the intersection. Because remember, intersection corresponds exactly to this where they overlap, this little crescent where they overlap, which is why we subtract that off, right? You add everything in E, everything in F, but now you've double counted the stuff in the middle, so you take it away, and that's going to give you everything in each event. Okay, so let's think about an example where we use the inclusion-exclusion principle. And most of these problems are word problems, so it's kind of wordy, but suppose 30 people enter a contest and each person is equally likely to win. Okay, so maybe it's like a random drawing. And then of the 30 people, 18 have long hair, 15 have dark eyes, and 25 have long hair or dark eyes. And it's important to remember that when you're talking about probability, or allows the possibility of both being true. So when we say 25 have long hair or dark eyes, they could have only long hair, they could have only dark eyes, or they could have long hair and dark eyes, and that's fine too. Okay, so there's our breakdown, and we want to find the probability that a person wins the contest who has both, okay, both long hair and dark eyes. So remember, let me get my black pen. So remember, or, in probability speak, or is the union, right, the U symbol, and is intersection, this cap symbol. Okay, so we want the probability, so if we let L be the event that the person who wins has long hair, and if D is the event where the person wins has dark eyes, we want the probability of L and D. That's what this is asking us. Find the probability a person wins the contest who has both long hair and dark eyes. So this is what we want. Now the inclusion-exclusion principle states that the probability of L, and I'll just use the one I had written in green above, the probability of either event occurring is take the probability of one event, add the probability of the other event, but now you double counted the stuff in the middle, so subtract the stuff in their intersection. Okay, so we just have to figure out, right, this is the one that we want. So if we know what the other three are, then we're fine. We can solve for this. And in fact, we do know what the other three are. That was what was given to us in the color-coded information above. So what's the probability of L or D? Well, 25 of 30 people have long hair or dark eyes. So there's a 25 out of 30 probability that someone wins who has either of these characteristics. And similarly, the probability with someone with long hair winning is 18 out of 30. And if you go back up and look, dark eyes was 15 out of 30. Okay, so now we've got this equation, but there's only one unknown, so we were able to just solve this. So we're just going to do some simple algebra and solve for this term. So 25 out of 30 equals, and by the way, I recommend you do not simplify any of these fractions until you get to the very end. Because right now, right, they all have the common denominator of 30 because they're all out of 30 people. Now, you could simplify this and say, oh, 25 over 30, that's 5/6. But that's not really what you want to do here. It just makes the math a lot easier if you don't simplify until the very end. So 18 plus 15, that's 33 out of 30. Okay, so then if we subtract this 33 out of 30 from both sides, these will cancel out, and this will give us negative 8 out of 30 is negative probability of L and D, which means that the probability that someone wins who has long hair and dark eyes, if we just multiply both of these by -1, is 8 out of 30. And now that we've got it in its final form, we do want to go ahead and simplify. So both of those are divisible by 2, so it's really going to be 4 out of 15. And in general, a fraction is fine. A decimal is also fine. Remember, probabilities are always numbers between 0 and 1. So take care not to put the percent chance, okay? Percent is different from probability. A percent is a whole number like 10%. What you actually want is the decimal, the percent as a decimal, because a probability is always between 0 and 1. So this is an example of how we use the inclusion-exclusion principle, and it's used anytime you're talking about two traits that are allowed to have overlap, like someone has long hair and potentially also dark eyes. It's not going to be used for things that are mutually exclusive. For example, you wouldn't use this for someone who has light eyes and dark eyes, right? Because that doesn't make any sense. There's not going to be anything in their intersection. So you use the inclusion-exclusion principle when there is some overlap in the events you're considering.